So, I posted this quiz on my community page a few weeks ago and I got some interesting questions. So, I will try to answer those today. And if you have any more questions like this in the future, just feel free to ask them in the comment box. So, for those who haven't seen the quiz yet, so the question was, can you guess at what speed, as a percentage of the speed of light, the protons are circling around the Large Hadron Collider? The correct answer to this is the last option. The protons are traveling at 99.999999% of the speed of light. So the first question that was asked was, well, how come they are not approaching infinite mass then? Although the concept of relativistic mass is not commonly used anymore, it can be seen almost as the total energy of the system. So the protons at rest have a mass of about 938.3 MeV over c square, is mega electron volts. And at the LHC, they are accelerated to an energy of 6.8 tera electron volts. So if you translate that into the terms of relativistic mass, it comes out to be 6915.5 times the mass of the stationary proton. So you could say that the protons at the LHC behave almost as if they are 7,000 times as heavy as their rest mass. But I got another follow-up question. So they would then be an infinite mass with another fraction of speed of light added. And if so, wouldn't that destroy the universe? This is where it gets really tricky. So in theory, if you could add another 0.000001% speed of light to this proton, then we would have infinite mass. But in practice, it is never possible to do that. To accelerate an object with a mass and has a velocity which is lower than the speed of light, we will have to supply infinite amount of energy to make it travel at the speed of light. Because as you know, both mass and energy are equivalent, and the total amount of mass and energy is always conserved. So you cannot get infinite mass without supplying infinite amount of energy. To visualize that, let us look at some plots. In this first plot, you can see that it requires very little energy to go from rest to like 10 to 20% of the speed of light. And as you can expect, the velocity to relativistic mass graph is roughly quadratic because the kinetic energy k is equal to half mv square. And now, this is what it looks like at the LHC energies. Trust me guys, I did not draw a straight line. It is the same equation and the continuation of the previous graph. The curve just never touches velocity equal to speed of light. And the more energy you supply to it, the mass just increases and the velocity basically stays the same. Okay, here are some more interesting plots. To take a particle to 90% of the speed of light, it only requires 2.2 times its mass energy. And if you give 7 times its mass energy, you reach 99% of the speed of light. But then, going from 99% of speed of light to 99.999999% of the speed of light, it actually takes 1000 times more energy than what it takes to go from 0 to 99. It is almost as if universe hates perfection. It is kind of like having Asian parents. It doesn't matter how much you improve, you are never good enough. So on that note, if you liked the video, please like and subscribe, and see you with more content like this.